Don here in Florida, home of the newlyweds and nearly deads. Today we're going to talk about the Craftsman /Atlas lathe. These have been around for a long time. I think originally developed back in the 1930s. They built them right up until the late 70s, I believe. This particular model is around a 1970 model. I remember actually when my dad got it. He got it in boxes from Sears Roebuck and put it together in his basement. I actually remember the assembly procedure for this lathe. This is a 12-inch swing model. I think it's somewhere around a 20 to 24 inch between centers. The later versions, of course, were built under clausing, and there were a few smaller differences to them, but nothing really worth mentioning. I think it's kind of interesting that my dad bought this lathe. He worked in Bryant Grinder Division in Springfield, Vermont, which was probably the most advanced machine shop, not just in the US, but in the world. They were the first machine shop to ever put in a CNC machine. They were the very first to put one on the line. And they were renowned for their parts. They sold parts all over the world, including the Russians, which was a big no-no back then, and it raised a lot of eyebrows. But interestingly enough, working for probably the most high-tech precision company in the world, he goes out and he buys an Atlas, which was probably the most entry-level lathe you could buy. This was pre-Asian import type lathes, and this could only really buy a US or maybe an English, or if you were well-heeled, a European, German-made lathe. So him actually turning around and buying a lathe like this, it made you wonder. I mean, he had every piece of machine in the world available to him. Great big Jones and Lamson turret lathes and big Monarchs and, you know, Bryant universal grinders, things like this. He had everything he needed, but yet he went ahead and bought something like this to use at home. Thinking back on this, there's really nothing odd about that. The Atlas lathe or the Craftsman lathe, you know, the Southbend, the Logan, they were all entry type lathes. Great for hobbyists. A lot of small shops would buy them, and I know through the years of working in different shops in different places in the US and around the world, I would see lots of these Atlas lathes crop up in small automotive shops and you know, plumbing shops and all kinds of different places, along with, of course, Southbends and Logans. And so they were put to good use, not just by hobbyists, but by shops. And I'm not talking production shops, although there may have been a production shop out there that might have had one of these on the back. Anyway, we're going to go ahead and talk about how to get the most out of your Craftsman Atlas lathe. And this, I guess, would also go for Southbend, Logan, and probably even a lot of your smaller Chinese lathes at this point. Where you really should begin is right here in the book. Go ahead and get yourself a book that goes with the lathe and learn it. Okay. Wrap your head around your lathe, know it, know how to use it, know the safety procedures when working around the lathe, and of course always practice good safety. Okay? Get your head wrapped around it. I would not suggest getting on your lathe without getting at least a decent night's sleep. You know, how many guys have come to work and totally messed themselves up because they weren't paying attention? So in the machining or in the machine shop realm, you really do need to be paying attention. Drastic things do happen when you don't. Number two would be upkeep and adjustments on your lathe. And so let's get a little bit closer in view here. Okay, as far as upkeep and adjustments go, you always want to make sure to keep your lathe clean. Try to keep it as chip-free as possible. Keep it lubricated, especially the ways. Lubrication is vitally important with these. The main adjustments that I really do like to emphasize are, one, the spindle bearings. And the spindle bearings are adjusted back here on this nut right here. Paying attention to those spindle bearing adjustments will really go a long way to reducing chatter. And as long as I'm under here, notice that we do have oiling points. Also, don't be afraid to write on your lathe. Notice I wrote oil here Always want to make sure to get into those oil points that you really don't pay attention to on a regular basis. The other adjustment that I think is really necessary if you want to maintain accuracy in your cuts is to always check your centers. You want to make sure that your tailstock is adjusted properly so you're not cutting tapers on your work. Okay, so invest in a bar or make one and keep an eye on your tailstock. Okay, and the last of the big three adjustments you want to make are going to be leveling the bed. You want to make sure to do this, get yourself a level. I've done just fine with these cheap digital levels. I think I got this one for $20. I know that this is good. I've tested it against my Starrett bubble level, the 12-inch, and it's dead on. So I don't worry too much about those digital levels anymore. I think it was my son's iPhone that actually turned me on to them back in the day. But to get the bed leveled, I put in these adjustable feet here, and you can see them under here. And those I think were just for a woodworker's lathe, but this lathe is light enough that it was just fine with those. I think they were rated at like 500 pounds each, and I think the total weight of this is about 550. So with the big three adjustments, make sure your spindle's adjusted in, make sure your tailstock is adjusted, and your ways are leveled. You're on your way. Those are the big three. Make sure they're all good. Anything else really would be attributed to wear, and that's one-off stuff that you'll have to take care of. And of course, know all your lube points. The Atlas has quite a few lube points. If you move this in, you know, you have your obvious points with all the little cups here, but if you move this in, you'll also see, and it's even engraved right here, oil. You want to oil these points here and here, okay? But again, this is getting back to your book. If you have a book and you have a lubrication chart and you pay attention to it as you're doing this, within a few times, you're going to remember all these, and it's not going to be a big... Okay, something else you want to pay attention to is tooling. The nice thing about the Craftsman Atlas lathe is there is tons of tooling available, both original equipment and aftermarket. The wide array of these is astounding with the Atlas. Having the 1.5 by 8 spindle screw on, it just makes it an incredibly adaptable machine. So get tooled up, and the nice thing about the tooling for the Atlas, of course, like I said, is that it's just not that expensive. I can buy all this tooling here for less than what one chuck would cost for my Monarch. So just kind of keep that in mind. Okay, the last thing I want to talk about with the Atlas lathe is modification. The beauty of the Craftsman Atlas lathe is that it's just so easy to modify, to get more out of it with. Now, I've literally doubled the depth of cut and speed that I can cut on this. But what really speeds you up on the Atlas is this. Everybody knows it, man. The quick change tool post. Okay? Don't fool around with the old lantern style tool post. That's just going to slow you down in the end. You can switch out tools really on the fly with this thing, going from one type of cutting to another. Cut off to turning to grooving to forming, whatever you want, just very quickly with the quick change tool post. And yeah, it's not original to the Craftsman Atlas, but that's the beauty of the Craftsman Atlas lathe. It's very adaptable, like I said. For example, I bought this Taiwanese center rest, and I had the original Atlas center rest, but this one was a little bit bigger, and that's the original reason I bought it, so that I could put larger parts into it. And I did have to modify it, which was no big deal. I just milled this out here. You can see there's a piece of V-way there, that's gone. But I milled this out, and I put an aluminum plate in the bottom because aluminum doesn't score, and that allows it to stay centered within the ways. And just used a clamp on the bottom and started using this. As it turns out, this very cheap, I think I bought this for $20, this very cheap Taiwanese center rest actually worked much better than the original Atlas center rest. It was stiffer, reduced vibration, and just worked all around better than the original Craftsman. So I just went ahead and sold the Craftsman piece and use only this now. And I'm very happy with it. And in the end, I more than paid for that just by selling the Craftsman part. Okay, so my first modification was the quick change tool post. After I put on the quick change tool post, I had been having problems with the motor in this unit. It was a 3/4 horsepower AC motor. There was originally a barrel switch on top here that turned that AC motor on and off, and it would forward and reverse it. The thing I didn't like about that AC motor was that as soon as you turned it on, and especially if you were engaged for threading or something, the crash and clang through the machine was just horrendous. It was horrible. And eventually that motor burned out, and I went to try to repair it, but it seemed to be shorted within the windings itself, and I said enough's enough. I just got rid of it. And what I decided to do was this. So what I did was this. I took out the original AC motor, which actually sat up here, and it had a belt drive down to an idler shaft here with another set of pulleys. So I went from pulley to pulley out to pulley set that go back up through and into the spindle. I got rid of the top AC motor that was up here, got rid of the carrier and the pulleys that were down here. So I took out 2 pulley sets, and I got this 1 horsepower DC motor. Now this is a 90 volt DC. This originally came off a conveyor set that was down at one of the factories down here just outside of town, and a friend of mine did maintenance on these things, and he said this was one that they'd put in, and when they decided to reconfigure the conveyors, this was almost a brand new motor. They basically had a half a dozen of these that they just weren't going to use, and he threw it on the back of his pickup and brought it up and gave it to me. And this, like I said, this is a 1 horsepower motor. I didn't have a driver for it, so what I did was I went ahead and I bought one of these dart controls, and this is fully adjustable. It allows me to start the motor, and when I put the switch up, it soft starts. So I adjusted for the soft start, and of course it's fully speed adjustable. You can bring it right down to a crawl if you want. The one thing you do have to know about these control units for the DC motors is this. They have what's called a load compensating adjustment pot. You want to turn that load compensating adjustment pot all the way to 0, because what it'll do is it'll cause a hunting effect on the motor, because it's always looking for a load, and if it doesn't have a load, it'll cut the power. So if you turn it all the way down, it'll be under full power all the time. So keep that in mind if you ever decide to go this route. With a spin-on chuck, you may end up with a chuck spinning in the ways, and ask me how I know. So make sure to do that. Adjust your minimum voltage, which would be down here, to however fast you want it to go. So I mean, I'm at a dead crawl right there at 1, off at 0, dead crawl, and then of course all the way to 90 volts at 10. So this allows me to create a nice variability in drive speed, which is nice. So back to the motor. I got the motor in place. I mounted it on this plate. Now there were screw holes in the lip of this casing here, which I just bolted these channel iron pieces onto across from side to side, and then I mounted the plate on a hinge on one side back here, so this is totally adjustable. And then over here, of course, I had to put a groove in here, and this is actually semicircular because it doesn't just straight, it goes around. So what I did was I put a bolt in there and scratched it as it ran through, and then I knew the angle that I had to make it at, and then I just drilled holes and ground it out, and it works fine. The bolt comes in from the other side, tightens it, so I can adjust the belt tension on the other side of here very easily. And there we have it, a DC driven Atlas lathe. This motor, by the way, I think it maxes out around 1700 RPM. And when you're looking at putting a motor, either an AC or a DC motor on a lathe, you want to try to keep the RPMs, the revolutions down, or the motor rating in horsepower is usually a combination of, or a multiplication of, the torque times the RPM. So you can have half as much torque and run it at a higher RPM and still have the same horsepower, or you can have a lower RPM and a higher torque. And really what you want, if you want to push through metal, is torque. So lower RPM is going to serve you better for pushing tools through metal than, say, a higher RPM motor will do. And I see a lot of these guys will go out and they'll use the motors off treadmills and things like these that turn up like 5,000 or 6,000 RPM, and they really don't have tons of torque. That's not what they're really built for. This type of motor that actually moves a conveyor belt, it has to move a lot of weight, or at least get that weight going and keep it going. And it doesn't have to go at a huge high speed. Obviously it's on a conveyor. So they need a torquey motor, and this is a very torquey motor. So just kind of keep that in mind if you're going out looking. The other thing I did was I took the original barrel switch that was on the top and I moved it down here and ran my wires through to give me forward and reverse. And I put it under here for a reason. I didn't want to have it on the top and be tempted to use that reverse. With a threaded spindle, you really don't want to be running this in reverse. And I mean, sometimes you need to creep it in reverse. So I do have the ability to put it in reverse, but I want to be darn well sure that I'm only using it when I need to use it. So therefore it's down here. Obviously you see some other wiring under here. I put a outlet down here to run different things. As long as we're down here, we'll show you. I put in a 10 amp AC to DC transformer. This takes 120 in, converts to 12, 14 volts out DC. And I needed that for my Electrodrive, and we'll get to that in just a second. The outlet down here is also nice because I can switch everything off right at this point, and I have all my cables that I need for anything I'm doing right handy. So it really just makes it comfortable for me. Okay, if you've got an Atlas lathe, you probably realize that the dials on your machine are kind of small and the numbers are small as well. My eyesight is particularly bad, so I went ahead and put on a couple of these Easy View DROs. One for the carriage, allows me to see how far up and down I'm moving on the carriage when I'm cutting. So if, say I want to cut half an inch down into a piece and hit it every time I can. The other's for the cross slide, which allows me to, let me zero that, which allows me just to take out 1,000s, 2,000s, half a thousands, whatever I want. It's very nice, very easy. I've gotten used to using this DRO. I know it's not the best or the fanciest on the market, but it definitely works in this application, so I have no qualms here. The beauty of this is that it doesn't use glass slides. It uses the metallic strips. Let me show you those here. Okay, it's hard to see the one on the back. I put an extruded aluminum square piece back here directly onto the, and you can see it move with my finger, directly onto the carriage, and this guards and protects the metallic strip on the back, but it also protects the sensor, the pickup on there too, so I'm not getting any grease and oil and chips and stuff down on there. This guard here, let me take this out of the way, a friend made up for me with his 3D printer, and it came out great. The tape's just from another job, that's not anything important, and it came out great. It covers the entire metallic strip end to end. If we look at it, what I did was I just ran the metallic strip above the screw and into the sensor. I set up a bolt here that allows me to hold it and adjust it. And as you see, as I move in and out, see, it allows me to adjust this up and down so I'm not putting any stress on it. And maybe I can get the other piece back here as I move it up and down as well. So this worked out really well. So keeps everything clean. It allows me a very accurate positioning of my tool when I'm working. Okay, like I said, my buddy made that up with his 3D printer. Came out excellent. It's been heavily abused, but still works just fine. And all I had to do was just make up this retaining nut out of aluminum. And it makes a nice spot just to put my cutting oil, so I have it right handy when I'm doing some cutting. So I'm really happy with that. All right, and the last big modification that I made to this that really makes a difference is my Electrodrive. And this is basically just a windshield washer motor off a truck, 12 volt. And of course it has its own gear reduction built right into it. You don't need to mount these behind the machine and belt drive them. They have more than enough torque on their own. I made an L plate that it mounts to. I took a 3/8 piece of square stock and bored it, or drilled it and pinned it onto the shaft that comes out of the windshield wiper motor. And on one of the bolts that comes out of the windshield wiper motor, I made this aluminum guide, and it's got a milled in guide slot right here, because I have a collar and basically a socket that was turned to fit onto the screw at the end of the shaft here. So I can turn this back like this, come off the shaft, and the shaft's free to move. Okay, say if I do want to do some threading, I can turn that off of there. And then if I want to go ahead and just drive it with the Electrodrive, I can just snap it on. Now, originally I had this fancy over center spring thing. This is what this is all about right here, that did an over center snap to supposedly hold this in place and hold it back. But it got a little finicky, it got a little jammy, and eventually I just took it off and put that guide on, and that works just as well. I don't really have an issue of this sliding in or out. Once it's one direction or the other, it tends to just stay right there. So that's not a big issue. I bolted this down into my pan here and wired it back to the, actually I didn't wire it straight to the transformer. The transformer simply runs power to a control unit, which is back in here. So let's get this down here and take a look. So this control unit right here, it's just a cheap one. You buy them on eBay. I think they're like $10. The transformers themselves are also like $10. And I put in this switch here, so at this point I can turn on the transformer. So this runs the current back to the transformer. I have a light here so that I know that it's on. I don't like to have things without lights. I like to know that they're on or that they're off. I hate leaving for the day and having stuff left on. So if I have a light, when I turn off the lights in the shop or in the garage here, I can see that glow and I know to come back and turn it off. Once the transformer's powered up, I can turn it on like this, and this here is not speed, this is percentage of power. So right there I'm at 100% drive, and if you come up here you can see the motor is driving along at 100%. So at about 100%, maybe 75% is the lowest speed you can get here. So this actually allows me below 75% to drive at a much lower speed, and I can drive this all the way down to nothing, and usually I'll run it right in about 30 to 45% of its maximum output, and that correlates directly to speed, of course. And you know, you get a feel for this. I don't need to know the exact surface feet per minute. I've got a good handle on that just by look and feel. Of course, it's reversible. You can change the direction of this, and this is handy. Say you're, knock that down, you're going along like this. I'll speed it up here. All right, and you want to reverse it, you don't even have to disengage it. So, and you do need that reverse, because what I found out is if you're going into cutoff mode, Okay, it has to be in the reverse direction. So I'll bring that back down. Another thing I want to talk about with this is this. Most of these, I'm gonna turn that off. Middle is off, by the way. That's forward. Most of these windshield wiper motors have 3 different wirings you have to worry about. You have a high speed wiring, a low speed wiring, and then a park mode. Okay, the only thing you have to worry about or dig into is the low speed. And on low speed, you simply have to ground the motor. That would be your ground side, and then find your wire to your low speed, hook into that, and you're on your way. Don't even worry about the park. You can cut that right out. And interestingly enough, your low speed is your higher torque, and we want to be in low speed because it allows us to drive this carriage at a much lower speed than it can be driven mechanically. And high speed would honestly just be too much for this. So always look for your low speed. The torque is more than enough. Normally these motors, when they're hooked on your car or on your truck, they're given a 15 or 20 amp fuse. Now the 15 or 20 amp fuse means that they can perform up to that amount of wattage, voltage times amp wattage. They can perform up to that amount of wattage, and that would also include to horsepower rating. These can actually be too powerful for your lathe. I only run a 2 or 3 amp barrel fuse to this, and that allows me to cut the power at a certain point, which is a safety thing. Because what I found was this: if you have too much power going into that, you can overpower your chuck here. You can actually stop that up, you can stall it. And that lower amp fuse has actually saved me. I once had this going into automatic cut mode, and this side of the quick change tool post actually came up against my chuck here, went right up against it. And if I had allowed a higher amperage to that motor, I could have probably created some serious damage. In that case, the 2 amp fuse that I had blew, and it just simply stopped. There was no crashing or upset or anything. It just simply quietly stopped. I looked around, why isn't it cutting anymore? I looked down, oh, this isn't moving. Why isn't it moving? The fuse is blown. Why did the fuse blow? Oh, so I do run either a 2 or 3 amp fuse in that, and that's plenty, and it acts as a safety stop for anything you may be cutting into. And as far as cutting shafts and stuff, if I'm turning, there's absolutely no issue. It goes along just fine. Let's take a look at that. Okay, so bring her up to 36%. And so she's rolling right along nicely. Let's just see how nice this cuts with Electrodrive. We don't have any clanking or gear noise. And I probably could have taken a little bit deeper cut than that. But I can speed it up on the fly, which is nice. Just like that. Or slow it down to dead crawl just as well. So hear how quiet that is? It's just, I mean, the camera picks up way more noise than what I hear in the shop here. But it is very, very quiet. Move that back. Take a little more cut here. Say you're a little off on that, you can speed it up to get it into the cut and then drop it back down. And it'll cut right along nice and speedily here. And then I have that cut where I pulled out. I can slow it back down before I come into that cut. There we go. She didn't even feel it, did she? Another thing people don't really think about is the power loss through your gear train through that feed shaft. But that power loss has been completely taken away. You have a whole separate way to power this carriage now, other than through the motor itself and through the gear train. And it's a savings. It's quiet, it's comfortable, easy to use, and you can turn it on and off on the fly. You don't have to be shifting gears or anything like that. So I'm really happy with that. So the main changes that I made on this to really bring this into the modern era: DC motor, DRO, quick change tool post, and Electrodrive. And by the way, one last thing on the Electrodrive. Yeah, if you set one of these up, pay attention to your tailstock. Be sure to leave space for it to slide off of there, okay? In this case, I actually had to grind it just slightly right here to allow that tailstock to slide out of there. Okay, I guess that just about covers it. Some of you may wonder why I'd spend any time with the Atlas lathe, the Craftsman lathe here, other than at this point it's probably, or would probably be considered family heirloom. I mean, my dad bought it, my brother used it for years, or a few years anyway. It's always been a part of the family. That's one side of the house. The other reason, of course, is the Craftsman Atlas lathe is still a viable piece of equipment. Like I said at the beginning, I've been in countless shops where I've encountered these in the back corner, and they're still being used years and years later. This is, over a 40-year-old machine at this point, and it still cranks out a lot of good work. Matter of fact, I have both this Craftsman lathe here and I have the Monarch lathe sitting right over here behind it. I still use this Craftsman lathe at about a 10-to-1 ratio to the Monarch, simply because I have more tooling for it. It's much faster to set up. It's easier on your body. The bigger the machine, the harder the work's going to be. That's all there is to it. And I can come out here and I can knock out a lot of stuff really quick on this lathe. Okay. A lot of things that you do don't require massive precision and massive cuts, especially in the maintenance fields, and that's where I've been almost my entire life. So this turns out to be a really, really good tool for that sort of thing. Now, yeah, when the chips are down, you need to turn a lot of material really fast, and it has to be really accurate. Bam, you got to get on the Monarch. There's no denying that. But if you own an Atlas, Southbend, Logan, don't allow yourself to be looked down on. These are great machines. They can do a lot of great work. So I know there's guys that, the big pickup truck type guys, oh, why are you driving a Toyota Corolla, or why are you driving a mini pickup? Well, you use what suits you, right? And in most cases, for most small maintenance type jobs, or even some of the larger maintenance jobs, this easily suits those applications. So I'll just leave it at that. And again, I want to thank y'all for watching, and from Florida, Don out.